Okay, so I'd like to present you research of a system for monitoring self-tests for COVID-19 using neural convolutional deep networks. The rapid development of technology and the widespread use of the internet create a need to improve systems and methods for self-testing for COVID-19. Ensuring the accuracy and speed of test results was important to control and prevent spread of the virus. The research objective was to develop an implementation for a system to control the conduct of self-tests for COVID-19, ensuring high accuracy and speed of results. So modern methods of deep learning, image processing, system design, and web programming technologies were used. We decided to use convolutional neural networks. And here you can see an example of such a network. Requirements were to develop a microservice that uses computer vision to analyze images in order to control the correctness of COVID testing independently. The service should be accessible via web requests and perform analysis in real time. For architectural solutions, we used the most popular programming language for computer vision tasks, that's Python, and used modern computer vision's models for tasks of object detection, detection of face and nose meshes, and image classification. Developed a microservice accessible via web requests, and standardized the microservice for development to different platforms, deployment to different platforms, and used a cloud service to provide load scaling. Python was a programming language. Media pipe face mesh is to detect face and nose meshes. YOLO v5 model for object detection model that detects swabs on the image. OpenCV library to detect white lines in the area of interest. Shapely to build polygons of nose elements. Fast API to develop web API. Docker to ensure cross-platform deployment. And GCP Kubernetes to ensure scaled loading. For algorithm, we had following steps: face detection, determination of the swab, determining the direction of the face, finding the landmarks of the nose, finding the end of the swab, and checking if it is in the nose area. For face detection, was used media pipe face mesh. For object recognizing, was used YOLO v5. As a training data, we used a few datasheets. A datasheet with 130 images of people holding swabs. A datasheet using transformations to artificially expand the number of images, 780 images. And additionally, images were obtained using a cut from the swab usage video, more than 3,000 images. Such software development environment was used. For assessing accuracy was used mean average precision MAP matrix to evaluate object detection model. The training consisted of two experiments. One on the initial dataset with 780 images with such results, and a second on the extended dataset with 3,126 images. And on the training data, we acquired MAP50 of 0.85, and on the test set, we acquired MAP50 equals 0.8. The YOLO V5 model is used to detect the swab object, which was previously trained on the extended dataset. The YOLO, you look only once algorithm, provides an efficient and accurate location and outline of the swab in the image. The image is processed to improve the accuracy of swab detection. For this purpose, OpenCV library is used to optimize and reduce noise. Media pipe face mesh is used to accurately detect the facial and nasal features. Facial landmarks are used to determine the direction of gaze and the area of the nose, where the tip of the swab should be located. Based on the swab detection and facial landmarks, the position and orientation of the swab relative to the face and nose are accurately determined. OpenCV is used to optimize image processing and determine the exact angle of the swab. For integration and testing, all components of the algorithm were integrated into a single system and tested on a variety of images and scenarios. Testing included trying the algorithm on images with different lighting, angles, and backgrounds. The details of the image pre-filtering to detect the swab line by emphasizing the byte elements are shown here. And the results. Let me show you a short 30-second video. You can see a face detected, face position, swab detection, and detection of correct position of the swab. So, conclusions. An effective system has been developed to control the conduct of self-tests for COVID-19. The use of advanced technology, such as YOLO V5, Media Pipe Face Mesh, and Fast API, ensured high accuracy and efficiency of the systems. And prospects. It's possible to continue research in machine learning to improve accuracy and to expand the system's functionality, taking into account the possibility of integration with other medical devices. Thank you for your attention.